class session, I'd like to invite our principal, Dr. Nambiar, to share a few words with us.
Okay, good evening, everybody. It's very exciting for me to be a part of it because Thomas was a very, very dear student of ours. He is one guy who put DBIT almost on the national map. I don't know, Thomas, whether you put us on the international map, but I know even the Malayalam newspapers were full of your invention. And I know the excitement which was there on the campus when you got your trike onto the campus and when we all took a ride in it. And also you exhibited it in so many competitions and you got a lot of recognition. So that was one instance where people, I think you were responsible for a lot of admissions into DBIT subsequently, yeah, Thomas? Because children were, because I think the students were so excited about the kind of work that you have done. So my dear students, let me present to you one of our most innovative students of mechanical engineering who completely thought out of the box when he was probably a second year and a third year student and came up with a very, very unique contraption, which he called as the trike, T-R-I-K-E. And he, along with his team members, designed it. They exhibited it in so many places and it got so much of recognition. So always it's a pleasure to welcome such a student. And I'm sure Thomas will have a lot of stories to share with all of you. So Thomas, once again, very, very exciting that I could reconnect with you. Welcome again to DBIT, maybe, you know, in a virtual format, but someday I do look forward to welcoming you actually on campus. So with that, I now give it, I request Vidhu to please take this forward. Yeah, and I wish you all the very best, Thomas.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. Casting the world, forging the campus, shaping the universe, building the rest of the branches. Who are they? Undoubtedly, they are the mechanical engineers. We have a very special guest among us this evening. We cordially welcome the alumnus of 2015 mechanical batch, Mr. Thomas Tom. He is currently working as a trained engineering 2, a body validation engineer at Rivian in the US. Hello, Thomas. It is a pleasure to have you here. Over to you.
Thank you, everyone. Thank you for joining. And I'm so sorry to take your evening off Friday, but thanks for joining. I think this is a beautiful opportunity, especially great thanks to the alumni team who kind of organized it, give me an opportunity to share my journey. And I'm looking forward to share what I have. So just let me know if you can see my screen.
Yeah, it's visible. It's visible.
Okay. Sorry. Cool. So what you see here is basically in designer's mind is called a mood board. It's something like they use to design their inspiration. And I would be presenting what it is to feel like being a mechanical engineer. And any feedbacks, I'm most welcome to listen to. Here you can see some of my greatest inspiration. As you can see, the guy on the right hand is my source of all inspiration. And being a mechanical engineer, it's one of the coolest thing you can be because you are basically involved in every aspect of engineering. So since I have a very limited time, I would just definitely walk through what the slide is and then we can have a conversation one-to-one. As mentioned, I'm part of the 2015 mechanical engineering batch. The first photo that you see is not me. That's the place where I first interned at. It was basically during my first semester break, I think I owe a lot of credit to my father, who kind of always inspired me to do something, not sitting at home. And that internship kind of gave me insight into what is being a mechanical engineer. That was done in a tech fab, which is in Thane. It's a Wagle estate. I'm not sure how many of you are from Thane, but definitely that's a good place to explore a lot of mechanical industries. And that internship kind of gave me insight into machine shop, how to work with lathe, all the mechanical aspects in engineering. So from there, moving on to the second semester, during the second semester break, again, my dad was kind of asking, if you are interested into automotive, make sure you know all the skills. I think that is one of the biggest skills that I still possess, and that is one of the greatest asset I have. It's a 3D CAD modeling software called CATIA. And there are other wonderful softwares that you have in the industry right now, which a lot of automotive industry use. And I would any day recommend you guys to definitely do something out of the curriculum. And any skills that you do, don't just learn it for the sake of learning it. Make sure you guys kind of come up with some project, maybe not this big, or maybe it can be developing something small, and anything that you can do, just make sure you do it so that you have that on-hands experience even after you graduate. So the picture that you see is the CAD of the trike, which is the next image. That project, I'll deep dive into it sooner. And then on the right, you see the internship that I did. I did with SEAT as a mechanical engineer, and post which I got my first job in Torque Motors. I'm not sure how many of you are aware of it, but it is considered to be India's first electric motorcycle company. So by God's grace, I would say my career started with electric vehicles, and I'm glad that I'm still in that same industry. I worked there for around 1.5 years as a junior design engineer in the studio team. I'll talk a bit about that too. And then I took a break for my preparing before going for masters. I did masters from Purdue. And then, of course, the most interesting part is the Tesla, which is I did a 9-month internship, which was amazing. And I think I can share a lot about it in the slides. And right now, the company I'm working, which is called Rivian. So Rivian it's a startup again. They kind of make electric pickup trucks, which is a huge segment in US. And it's the world's first electric pickup truck that is basically used for off-road adventuring. So as Nambia ma'am mentioned, I owe a lot of thanks to you, ma'am, because what you see here have your inspiration as well. So the first image, I like putting images so that it speaks a lot of words, I feel. So each picture has its own stories. So that Jatswell basically is the initials of all the team members that we have in our team. So J for Joanna, Alan, Thomas, there's another Thomas, Chaco, Shruti, Vishnu, and Lijo. So that's Jatswell. And that logo we designed after we developed the whole project. We thought, let's name this project. We came up with the design. And so what you see in the first picture is how we developed using CAD. There was a lot of feasibility check. We went back and forth with Professor Vijay Kulkarni was a professor guide. We began the planning of this in second year. I think second break, the winter break, where I just thought of inviting people, asking how would any be interested. It began in our library, our college library. We sat down, we came up with ideas. We started off with electric cycle. Then a couple of meetings later, we felt, that's too lame, that's boring, it's easy to do. I think that brainstorming session kind of came into such a level, which is beautiful, and a lot of exciting stories I can share. The first image that you see on the top, where all of people are assembling the trike, that had a lot of improvisation. So when you design, it's a different thing. So it's easy to put your dreams into a CAD, but it's very hard to kind of get it into practicality, because that's where you kind of learn the engineering actual terms, geometric GD&T, and what are the tolerance stack up. The CAD seemed to be smaller actually when it came to building. We felt, that space is congested. The second image that you see is the solar panel. That has a lot of interesting story too. So you might be thinking that would be the most expensive part of this project. To be honest, that is the least expensive. And that is when we were kind of in search of a good solar panel. We went to the market on the Grand Road, the electronics store. I'm kind of just missing out the name. We had one electronic member in our team, like electronics engineer, who kind of helped us to find some small slabs of solar panel. And we were kind of thinking how to construct this on our roof. And a guy who was in the side of the shop, he's like listening to us, and he just walked up to us and he asked, like, what are you guys working on? So we kind of gave him the idea, and he came to our place and he saw the project. He's like, okay, I can give you the right panels. He gave, and he was supposed to be a government agent who kind of gives a solar panel directly at a subsidized rate. So I think when you kind of seek into more, the doors open. That's a good example, I can say. The next image is what you see is something that we had an engineering problem. So as you see, it's called a trike because it's 3-wheeled and 2 wheels. It's just called a tadpole. Jo Delta, it's like basically a rickshaw. And in this, definitely it's more stable. It won't topple like normal rickshaws. It has effective braking. But the challenge was the brake should be applied together. And we came up with a lot of concepts, tried, failed. And then we kind of thought, okay, let's take a stroll on the street. And then we saw a garage. There was a mechanic. And then I think somehow it was kind of a random. We just started talking to him. He said, oh, this is a problem. We have a solution to it. And then he just showed us this. So that's what you see is an Activa combi brake. That's kind of patented by Honda. Basically, it distributes brake in the front and rear. But what we needed was exactly that, which kind of we wanted to equally distribute. We just tweaked that design though. Then what you see next is Subnisa. That is a Vortex. First, I think, green project we got. So the first recognition we got there. Well, when we were developing this, we didn't know that we were making history. But I think later we came to know that we developed India's first solar electric trike, which is a big blessing. And then you might be thinking the story is over. Thanks to Nambiar ma'am, where I can say the second part, the bottom segment is the version 2.0. You can see a little black stripes. So basically we finished our project in third year. We thought of let's do something cool in fourth year. But I think ma'am's input of, work on it more so that, you kind of can explain what difficulties came in, how you overcome. What you see in the first two images, those damages that we had while transportation. The wheel got bent. It's not like a image that was stretched. That is actually the issue. We had to add like titanium alloy spokes. Then we had kind of a review feedback, what kind of issues we had on that trike. I think the entry and exit was hard in the trike. So we made a foldable handles. And the biggest, I would say, upgrade was the ECU that we developed, which had kind of a lot of. So if you look at the first version, if any industrial engineering would come, he would say you're sitting on a time bomb because no fire safety, it's like, and I can say the story behind that too. That ECU was developed because after the IIT Tech Fest presentation, we had got this trike. We couldn't get it back to the college, so it was in my home. And I think the dream that I could relate was when you see the first image, the CAD image, I had kind of dreamt that I would be driving that trike in my basement. And that day actually came when this vehicle was in my basement. I actually was driving that kind of. But after that, there was incidents that there was a lot of engineering flaws, which I can go deep. But since I don't have time, I screwed up the electronic circuit and the whole wiring got burned. That was because it got short circuited and you're dealing with a 48 volt, which is huge. And we thought that would be end of the story. And definitely when you kind of seek for it, door opens. We met with good industrial veterans who kind of helped us set up an ECU that can be safe. So there is fuse added. We added reverse to the trike. So earlier we didn't have reverse. We had to get out of the trike, push it hard. So it was crazy times. But in the second version, we kind of modified. Moving on to the next. So as Nam mentioned, these were the rewards that we reaped. I think it was more than we expected. It was all over the place. It came in one magazine. It was reviewed, and as you mentioned, ma'am, we actually went to a competition that was organized internationally. We think won third most popular, and NASA and Tech Brief, which host Create the Future event. So I think that explains, like, you don't have to expect something, but just do what you like, and the rewards come automatically. Moving on to my first job, what you see is the motorcycle that I worked on. That's the team that I worked with. I was part of the studio team. You might be wondering about a studio team. So studio team is, the powerhouse of the whole product. Any vehicle that you see in the market, that's a dream and a kind of ideas of a designer. And the guy who's on the extreme top left, he was a designer. He did the designing. So I can just mention what studio team does, and then there's a lot of aspects in automotive industry. So studio team is where they envision a product. So they come up with a mood board. They throw random pictures. If you walk into the studio, you will be wondering, what is this board about? Like some random pictures, you won't be understanding. But when that guy comes to his, it's Photoshop that he used for rendering, and then he renders that into 1:1 scale. He put that in a big 1:1 print. And then there is a chassis that is bought, a mock-up chassis. Then they stack up a lot of scrap so that it looks bulky. And then you slap on the automotive clay and not a normal clay. And then he starts sculpting. And once the sculpting is done, what you see on the top left is the sculpting of the bike. It's a 1:1. So as a bike looks like it, the clay model is like that big. And then the scanner comes, he scans the surface, 3D scans, and then that is given to a software called Alias, which generates those 3D surfaces into workable CAD files. My role was to basically to engineer those into a proper adding thickness. It's called Class B surface. Class A is what you see in front of your eyes. And then that gave me huge exposure to how automotive industry work. And what you see in the center image, I can say the sari guard was part of what I worked on. All these plastic panels, there are most of them that I could work on. I was fortunate enough. And then there came a time I had to kind of move forward. So I kind of called it quits, and then did a couple of internship after that before doing masters. And I think Rockwell Automation was the internship that I did, which had, I'm not sure how many of you know it, but it's basically a company that is well known for automating stuff. And what you see on the right is a tire building machine, one of the coolest machine. I hope if you guys have industrial visit, and if you get an opportunity to visit tire industry, it'll be awesome. And so the Rockwell basically does all the automation of that side. And when it means automation, there comes program logic control known as PLC. It's basically switches and relays controlled by a ladder logic program. That is where I kind of learned about how PLC works. And that was great. I think any internships that you do, none of them were paid except in Tesla. So basically, I kind of learned more than what I kind of, if you look at the monetary aspect, nothing was there. But I think learning curve was huge. Coming to the next L&T, that was a good project. What you see on the left is basically electronic throttle for excavator. It's a 60-ton excavator that I was given. Like they just told me. So I went with an expectation that I would learn something there. Apparently, I thought there would be a team, but I was the team. So they were like expecting me to develop something, and in a very short span of time. But as you know, like if you're put in a spot, you definitely will try to do something. And that project had a lot of insight into how Arduino works, and that has been used as a program in the upcoming models they have. Why masters? That was decided because I think I had a mechanical aspect. I was good at CAD. I wanted to know what could I do to integrate both the streams. So I decided to do masters and specialize in mechatronics. What do you? Hey guys.
Yes, you're audible.
Okay, I'm sorry. I think some technical fault happened. Can you? Yeah, I'm trying to. What do you see bottom as a nano material that I worked on called Maxine. Just let me know if I'm audible, if I'm lost. I think there was a technical fault. I think I kind of exited.
Yes, you're audible. Even the PPT is visible.
Awesome. I think there is a lot of things that I can deep dive into it. Coming to the Tesla, that was a great opportunity that I had working with one of the pioneers of electric vehicles as part of the closures team. So closures is a big team in the automotive industry. Closures basically stands for opening and closing in the vehicle. So it involves doors, hood, trunk. I can't show some projects because part of the NDA, but I have worked on a lot of projects as part of this internship. In Tesla, there's no like intern and a full timer. You're basically considered as a full timer, but you get paid as an intern. But learning experience was immense. I didn't know about seals much, seals, and the best part was I could proudly say I kind of worked on the world's fastest production model car. I think Model S played. I developed a small seal into it. It's called the inner belt seal, which is if when you open a window and there is two seals that guides the window. It basically dampening and water resisting. So I could speak a lot. I think I am eating up a lot of time. So this is a company right now I work for. It's called Rivian. So it's a startup. They have three programs. What you see is the left bottom is a SUV. The first is a pickup truck, and the middle is Amazon Prime van. So I'm this trail engineer is basically a early graduate. So when you pass out of masters, it's considered as an early graduate, and you get to kind of be in different teams for 2 years. Each team are roughly around 4 to 6 months. You get to decide which team to go, and that gives an overall picture of what industry is. I started with my rotation on closures mechanism. Right now, I'm with body validation. Closures mechanism, I was part as a DRE. In Tesla, it's considered as a mechanical design engineer. So it's various names, but does the same thing. You basically own a part. You're the champion of the part, right from the design, validation plan, PPAPing, like PPAP, basically anything like production. So you kind of are in charge, the GD&T, you are responsible. And then coming to body validation, what I do is basically testing the vehicle in its lifetime. Like, so in different industries, they kind of consider, so in Rivian, we consider a life of a vehicle 10 years. So basically we artificially simulate the opening and closing of cycles in a day. And then we multiply into 10 years and we artificially simulate in different environment. So cold, hot chamber, minus 40 C to 85 Celsius. Then you diagnose, and then you check for the failures, diagnose, and then you. So I can keep on moving. I think I'll just stop here. Thank you. And You can reach out to me on email, and my WhatsApp is on the same number. And I think if I couldn't explain on the slide, I surely can explain you on the questions. Yeah, that's all. I think, can you guys hear me?
Yes.
Yeah.
All right, Thomas. So there's one obvious question that comes to mind. What are the different entrepreneurial ventures one can pursue in the field of electric vehicles? For instance, say charging stations, battery replacement, etc.
That's a good question. Entrepreneurial, I think one of the biggest challenges that we face in EV is definitely the source of power, which is battery. People are striving to invent battery that has more density, charge density. They're trying to find the right chemistry of the battery that can give more output and less charging time, because the transition from a normal IC engine to electric is hard. So it needs to be seamless, so people should feel comfortable. I think one is, as you mentioned, charging infrastructure. That could be a good entrepreneur, because since we can see gas station in a couple of kilometers in India. If we can convert that into charging infrastructure is huge, and charging capacity of the charger is very critical. So that's a good. I think other good entrepreneurial thing that I could suggest is, since the world is, especially the Western side, they're trying to make it carbon zero by in a couple of decades. And especially some state has declared 2030. It's if you look statistic wise, I think we have around 2 billion vehicles in the world, out of which only 2% is electric. And if you're expecting the rest of the 98% to be electric, it's not feasible at very short term. So either come up with something modular that existing vehicle can be just swapped into electric. So a modular conversion kit, which is not expensive. Then if you can figure that out, that's a huge business, I think. Did I answer your question?
Yeah.
Yes, Thomas. That was quite interesting to know. So, now coming to higher studies, we would like to know which all fields of higher studies would be suitable for mechanical engineering, considering the market demand and all.
It's kind of tricky to answer, but when you're planning for masters, you're basically investing yourself into something higher. Should not be something that is dependent on what market is. I would say it should depend on what your passion is, because if it's like the market demand is varying. It's not like you cannot expect by the time you come out of the masters that demand would still survive. But definitely anything that you're planning for the future, you should plan that has a very sustainability. Let me take an example. If you're planning to do automotive engineering, you should not do something IC related. Hybrid is fine, but if you're going into engine design, those are going to be obsolete in a couple of years and decades, a decade out. So I think definitely plan for something sustainable in future. I think that's all I have as a suggestion.
That's certainly something we should keep in mind. Now, you have been known to create your own projects and have done your own research. Could you share some light on the reverse engineered robotic palm that you had made and the research papers you had written?
Sure. So I think the robotic palm that you mentioned, that is part of the curriculum project, where the subject was optimization of mechatronics. That was basically an introductory class to what mechatronics look like. And we had to develop a project that had some human interactions. It was a challenge given to us. So that robot palm that you see is basically an existing in the market, but we had to program it. So it had some servo motors, 5 servo motors. So we had to make it something interactive. So we came up with a rock, paper, scissor robot. So we basically give 3 buttons on the robot that basically simulates rock, paper, scissor, and the robot generates its own, and it shows the fingers like 2 for scissor, as you know, like the rock, paper, and then it decides who won, the robot won or the interactive guy. So that was the project. Regarding the paper, that came as I would say we had an international conference in our college then, and it was partnered with IEEE. And then we had a good content and we had a good project to showcase, and that gave inspiration for that paper. But I think that's a good question you asked. It's a good opportunity if you are into getting into research field, and if you want to kind of get more into technical side. It's always good to have papers in your bags. You don't have to kind of come up with very extraordinary thing. You just have to work on a concept, and then you produce the results and then present in conference. And think conference is a very good place to know what the future lies. And then you basically network with great people, great minds. You get to know what their aspect is. Also, I think in this, I would like to add, I was part of the Xanthium raising, which was the first SC club that we had. Our seniors came up with that club. Especially in the US, they value your passion more than grades. So grades is critical, but I'm not saying it's not, but definitely they would like to know what you did more. So Tesla and all, they just walk up to the competitions, essay competition. I'm sure in India there is big OEMs that walk into the competition. They hire on spot from there. They look at your engineering. They look at how you thought behind that design. So there's opportunities. So make sure you take part in a lot of competition. There's hackathon. Make sure you have a good exposure. And engineering, 4 years is amazing time. You should never kind of waste it. I think if people feel is lost out, it's okay. Past is past. Especially advice to 4th years, make sure your final year project is something you did it on your own. That's very critical. And whatever you're doing, make sure you know in and out, because that matters. And to the second years, I would say don't waste your time. Just try to learn something new and make sure you practice that what you learned.
Clearly, taking up self projects is very important, and it's evident that your efforts have rewarded well.
Yeah.
We would like to encourage the audience here to ask some questions to Thomas. You can unmute yourself and ask.
No questions.
You can put it in the chat box also. Okay, there was a question in YouTube. So it is like someone is asking, what is the scope of masters in US versus scope of masters in India?
I would say masters in US has a different. So in India, it's pretty competitive. It's not very easy to crack into one of the top institutes like IITs. You basically have to get GATE, which is definitely not an easy task. Whereas in US, all you need is a GRE, and it's not very easy either, but it's not very hard like GATE. I would say that pros is definitely you have access to the world-class labs. You can walk into machines that is worth millions, because here in US there is a government national NSF. They does funding to universities. They give funds to the professors, and they basically have to showcase what they're working on to get those funds. So they have like crazy equipment, and you basically get access to all those things. So that is something I would say pros. I think there are a lot of pros. This is one of the greatest thing I would say. Like you get more facilities accessible to you, and you kind of work with professors. And when you come to India, I think It's definitely, I'm not sure whether every university has that kind of capacity. Maybe I think Ma'am would be the right person to say that. But at the con side, I would say it's really hard to survive in US with how would you say, the cost of living. But I think, as it's an old saying, fortune favors the brave. So you take up that decision, you move forward. I think a lot of things might open up. Also, I think it's very good to know that your worth. In US, if you're a master's, there's a separate respect for you. Like people look at you, oh, did masters. It's a big thing here, and definitely cost that you earn is like skies apart. It's. Let me put a picture to this. If you think, I took definitely education loan. That was huge, but I could recover that within a period of 2 years, less than 2 years to be precise. So if that is what I can return in such years, you can understand what kind of price, like what kind of value you have in US as a mechanical engineer or any engineer as a master student. I hope I answered that question.
Yes. There's a question in the chat box. Can you tell us more about how you got into Tesla?
That's a very good question. I can actually. So I was doing, I think it was my third semester. I got done with my third semester and I was getting interviewed for Tesla. But when I think I had applied through their portal, but kind of didn't work through LinkedIn. But I had other friends who already are interning and they kind of tell me, how to approach Tesla. I think it's always good to kind of network with people in LinkedIn because they can guide you the best. I think I got an email ID and then I kind of, I'll tell you a short story. Basically, I spammed into one of the senior manager of closures. That was just a fluke. It worked out. Apparently, I got a invite from their HR team. They said, "Hey, we would like to interview you." So that worked out the way I never expected because I was just clicking and sending email that I would like to work with Tesla, blah blah blah. And the funny part was I was interviewed for full time. So they didn't get back to me soon. I was like wondering what's going on. And then they said, we are waiting on a person who can join immediately. But when they kind of requested for internship, they were like, there was an interview process. They just like put me into the internship program. So yeah, interview was hard. Tesla interviews are crazy. Interviewing for some CEO position. It's super grilling. You basically go through a couple of rounds. Just in first 2 rounds are with the mentors of the team and the reporting manager, and then you write a proper mechanical exam. And then after that, they call you for an on-site interview. You have to present your technical presentation. They grill you for the whole day. You walk into the office 9, you get out 5. And then it's a huge process. So it's grilling, but it's worth it. I see another question. How realistic or how possible is it to get where you did if we start now? Honestly, I won't say like the path I went would be like a formula to success. But if you are starting now, and I see you from second year, I would definitely say start working on a project that you definitely would love to and pursue in future. And before anything you keep in mind, make sure that once you take the step forward, don't back out. Because there are a lot of challenges. I think that journey is very important. That I would say more than reaching the destination, it's the journey that teaches you a lot. And it's coming to realistic. It's very realistic. It's not very hard. It's very easy. I think once you start rolling, you'll understand the flow. And once you kind of succeed, you'll think it was not a hard part. So it's possible. I don't know whether I answered your question. Neil, you can just unmute and ask me.
I got it. Thank you very much.
Yeah.
So next question, I think in YouTube is, what are the industries mechanical engineers get to work in the US apart from research?
There's a lot of industries. I would say, I think one of the big parts of US is a lot of big universities have incubators. Basically, I don't know if you guys are into watching series. There's a good series on HBO. It's called Silicon Valley. It's a good one. And basically, you either you tend to get up into innovation side and you kind of start a new industry. But US being very pro, climate, climate concern, like regarding the climate change concerns. So they are more moving into sustainable, and there's a lot of startups that's coming, and there's a lot of funding that is flowing onto such industries. So not only on electric vehicle aspects, but other industries are booming. So I think that's what I think I have answered. Maybe how important is chassis design and suspension geometry in the era of electric cars, given chassis and suspension cannot be kind of replaced. That is still one of the critical part. It's not like electric vehicle means it's completely electronics or electrical. Those are like one of the major part of the electric vehicle. And when you're talking about chassis design, you have different configurations. You have like a ladder configuration. And there is like a monocoque where the whole structure comes as one welded piece with the body. There's like a ladder and top hat structure. It each has its own advantage, disadvantage. And then there is a lot of innovation happening in suspension, I would say, especially with electromagnetic suspension, so electric vehicle, it just basically reduced a lot of complex system, like a lot of moving parts. It reduced the number of moving parts, but still have a drivetrain. So I think one thing to keep in mind is just being a mechanical engineer doesn't mean you have to know only about mechanical. It's always good to have an overall view, especially having a good hands-on electronic aspects as well. So try to be jack of all trade. Make sure you have good knowledge about it so that it's good for you. Basically, you'd be able to excel more.
So next question is, how many years of working in the US will you break even with a monetary investment in the masters in MS?
Again, I told you it's more of a personal story. I can't guarantee it will happen with everyone. Definitely, when you ask about the break-even point, it depends on how you spend it. So it's very easy to kind of earn. I would say there are ways to earn, but I would say the internship in US is valued a lot. Here you get paid for what you do, and you're not paid like normal. But I can give you an average. You earn around $20 to up to 15, 16, like big companies like Apple, Facebook. But you're talking about that range. That's a huge amount of money, and you're basically working 40 hours in internship, which I think you can save a lot of money for education. So you don't have to take from loan. You can basically invest in your education from your internship. Even if you don't get internship, that's not a big deal. You can still cover up the loan with a good job. Average picture, I would say, is as a master student, you are basically averaging around 55K to 100 to 200K, depending on the stream you are in. Definitely mechanical, you are expecting as a beginner around max up to 120. I'm not sure, maybe that more than that. But you're talking a huge number that kind of boils down that you can repay in very short amount compared to In your opinion, battery electric vehicle or hydrogen fuel cell electric vehicles, what's better? It's a very debatable question. Hydrogen fuel cell, it's still kind of in works. I would say it's not yet proven completely. There are a lot of commercial vehicles that are still available, but when you're talking about mass producing it, it's still kind of non-sustainable. To produce hydrogen, it requires more fossil fuel, and to kind of make it light, the vehicle is heavy because the hydrogen packaging is not easy. You have to contain that at a high pressure. Manufacturing of batteries, I would say, since there are a lot of other startups like Redwood Materials, which is started by one of the executives of Tesla, they're working on recycling those batteries. And I think currently we have a technology that is viable. So I think definitely the near future that you're seeing is definitely BEV. A fuel cell, I'm not saying it's not the future. It can be, depending on how technology advances. And I think, if you guys are interested in it, you should start working on it to take up some projects.
Since you worked on it, someone would like to know if you still think whether integrating solar power into vehicles is a feasible or a good idea, or should we focus on fast charging for now?
Good question. Working with solar panel, definitely it's not very efficient. We still haven't we haven't developed a panel which is highly efficient. I think the one that we worked had 50-60% of efficiency. The battery vehicle that we developed kind of lasted for, if you're just running on battery, could last for just half an hour to 45 minutes. And on solar, we couldn't validate it, but I think it could last a little more. But definitely fast charging would be the better option, unless I didn't get the question. So what was the question again?
So if you still think whether integrating solar power into vehicles is a feasible or a good idea, or should we focus on fast charging?
Yeah, so regarding the feasible idea, I think if the panel development, I'm sure every industry is working to optimize its own technology. And I'm sure a few people are constantly updated with tech news. Tesla is also working on integrating such ideas. And if they are into it, you are definitely knowing that they know what they're doing. So it's a feasible option. But yeah, compared to fast charging, I think remember I talked about transitioning to the complete carbon zero. I think we are planning to shift the whole infrastructure to charging infrastructure. So you definitely need a fast charging. So that's at a higher priority.
Yes, there's a question. It was anonymous. They want to know, how do we go about and where to start if we want to study abroad? I don't have any background in terms of preparing for abroad, and no one in my family has ever done it before.
So I think that's a question of many people. I feel like people have a lot of fear, especially when it comes to finance, especially people who haven't kind of explored before of taking such bold step. I think in short, I can say those are temporary circumstances, and the circumstances change. So when opportunities knocks your door, don't just leave it. If you think you need to do masters, I would say go ahead, pursue it. The finance aspect, there are a lot of opportunities in the Google. Just search it, and I think one of the things is called Prodigy Finance. They kind of give out loans without any collateral to certain universities that you apply for. But I think you should make up your mind first. Make sure you go with optimistic view. Don't think what will happen. Just I think the best quote that you can quote here is Ratan Tata's, where I don't believe in right decision. I make the decision and then make it right. I take the decision and then make it right. So go with that. what do you say, zeal. Like, just make sure you just pursue it. You have to pursue.
Yes, I think this was very helpful and what we needed to hear. So the next question is, did you get to drive a Tesla car or in Rivian also? How was your experience?
Okay, so that's whoever came up with that question, that's why I posted pictures of those cars that you see. Perks of being a Tesla. Definitely, if you are in Tesla, I'm not saying it is a must, but since you're working with a team, like I was working with closures, each team had its own fleet of vehicle, each model cars. They use it for validation of prototypes. Like any concept we have to test, we put it onto those engineering vehicles. And basically, as an intern or as an employee, you get to drive it to your home. So it was after work hours, you can take it home because you're working for the company. Even though during the weekends, you can kind of take it for a spin. I think that was one of the coolest thing I have done. So got to drive all the models of Tesla. Took it for long drives. It was fun, and I think the fun part was people where I used to live. They used to look at me like, "Dude, what are you doing for a living?" kind of thing. You know, every week you kind of change the vehicle. And that it was fun. So yeah, you get to drive a Tesla, and you're a Tesla. At Rivian, since we still haven't reached that level of manufacturing and kind of, but I see that happening in future. So I think, work hard, you will definitely get to see all those.
Yes, indeed. So is there any more questions? Or we can wind up with the session? I think we can wind up. So
Cool.
yes, you have to say something.
No, I'm good.
This was such an insightful session. I am genuinely so glad, so happy talking to you, Thomas, and getting to learn from you. I am sure even the audiences enjoyed this session. Thank you so much for taking your time out of this busy schedule you have. Thank you for accepting our invitation. There is a feedback form posted in the chat box. Please fill the form and let us know how it was.
I think I have a question.
Yeah, you can take that.
I think one question. But for charging these batteries, we are anyway dependent on fossil fuels. So I feel like for companies, I'm not denying that fact. We still are dependent on fossil fuel for charging those batteries. But as I mentioned, the carbon zero initiative that is taken by a lot of companies is trying to make it sustainable. So definitely the future is definitely not from fossil fuel. It's from sustainable, like wind energy, solar energy. I hope I answered your question, Tushar, but yeah, it's in progress, and definitely you can see within a decade.
There's one final question. Cybertruck or R1T?
Oh, Cybertruck is, I think when I looked at it first, it was like weird. I couldn't digest it, but when I saw it in real, it was so cool. Cybertruck, if you look at the size-wise, it's humongous. R1T is something kind of a small brother to it, so I cannot compare both. R1T definitely, because our Rivian has a lot of cool things. I think if you have time, just make sure you look into Rivian products. We have camping stuff, like we have portable kitchen. So basically you can cook while you're on camping. There's a lot of cool stuff that we have developed. So I would vote for R1T Rivian truck. Yeah. Anything else?
Audience are still enthusiastic. They're still asking questions. They like the session very much.
How the company reaction? I was there when they were unveiling Cybertruck. Oh no, I was not there. Sorry. Cybertruck, that incident, I think I was there. I'm not sure. I'm not able to recollect, but that was a big bummer for a whole engineering team. but the thing, what it was basically that cold rolled steel that was outside that was used like a armor. There's a window regulator that attaches the window. I think when the first guy hammered, Franz is he hammered into that edge. So any glass, like so I think the glass that was there was for the name. So basically, if you hit at those edges of those windows, the crack propagation is through the edges. So I think he hit on that, and that's why it made that the crack was already there. He just accelerated it by throwing that ball. But the glass is tested and proved. So I can vouch for it. I've seen that part. Laminated glass. Yep, that's the name. I am happy to see a lot of good questions. So yeah, thank you guys. Anything else? You guys can unmute if you want to ask, but if not, I think we can wind up.
Anyone else has any questions?
I think we can wind up.
All right.
Okay, cool. Thank you. Thank you, everyone.
Thank you for joining. Thank you for accepting the invitation.
Oh,
Also, a big
it was my
thanks to
pleasure.
the alumni community.
A big shout out to Anuranjani who kind of came up with this request. Thank you, Anuranjani. And I think I'm very happy to always come back to DBIT. Especially that's kind of where a lot of memories I have, a lot of good journeys. So yeah, and any questions, anything that you have, just call me or just Slack me. Sorry, not Slack, WhatsApp me.
I would request your audience to fill the feedback form. The link is pasted in the chat box. And now I would like to thank our principal, Dr. Prasanna Nambiar, our HOD, Dr. Sashikant Pawar, and also Professor Sachin Sheravia, Alumni Coordinator, and all the faculty members present in here for their valuable efforts and presence to sparkle this event. So coming to the end, on behalf of Alumni Committee, I hope you have enjoyed the session. Thank you very much.